Hi, my name's Ben Siggery and I'm the GIS Research and Monitoring Manager at Surrey Wildlife Trust. My day job involves getting evidence behind our conservation actions and increasing our interactions with universities. I'm also the PhD student associated with the Space4Nature project, and over the next couple of minutes I'm going to tell you a little bit about what my PhD is about and what we're trying to achieve. Space4Nature is all about using new technologies and improving the way we monitor our habitats. But what the satellites and the AI can't do is tell us what our restoration targets should be. So the role for my PhD research is to think about how we might set our restoration targets based in scientific evidence, and also thinking about what our ecosystems in Surrey used to be like in the past and what we can learn from that. The field of science my research is in is called paleoecology, which is the study of past environments. So it's looking at how ecosystems have changed over time, how those have been influenced by different events, including man's influence. So the way it works is that you'll look at things left behind in the sediments. So that might be biological indicators, it might be non-biological indicators, but commonly it's things like pollen remains, pieces of old charcoal, pieces of old seeds. It also might be things called diatoms, which are a type of microscopic algae. And using all of those things, you can reconstruct the way the environment used to look and what was going on at different points in time. That science is now being more and more applied to conservation. So we're looking at how we could restore to those older baselines what species might have been lost through an environment or how it might have been influenced by different things. Although it's not particularly well known in conservation, paleoecology has already helped us have some big wins in the environmental sector. The best known of which is when in the 1970s and the 1980s, it played a pivotal role in the acid rain debate. Paleoecology used diatoms to reconstruct the acidity of lots of different lochs in Scotland and also in Scandinavia as well, and they were able to prove that these lochs weren't acidic prior to the increase in fossil fuel usage. So we were able to link the increase in nitrogen emissions to the increase in acidity in these lakes, and that was eventually used to inform legislation that improved the way fossil fuels are emitted and the pollution from them is managed. So what have we done so far as part of this research? Earlier in the year, we went to Chobham Common to take some sediment cores. As you know, Chobham Common is one of the Space4Nature test sites, so I wanted to include it in the research as well. We went out to find some ponds that had been there relatively undisturbed for long periods of time so that they would be suitable places to take a sediment core. Using some old maps and as well as information that we had, I was able to locate a couple that had been undisturbed since the 1800s. So with a team of researchers from UCL who came down and lent us all their equipment, we went out and we took a sediment core at Glover's Pond and one at the Bee Garden Pond. So what that involves is going out into a boat into the water body and taking a big cylindrical tube and pushing that down into the sediment at the bottom of the water. You push it down as far as you can go, and then you put a bung in to create a pressure seal. Then when you lift it up, all the mud doesn't fall out the bottom, and you have a kind of record going down with the newest mud at the top, the oldest mud at the bottom, and then you will slice it up into 1 centimetre segments, bag each of those segments up, and then they go back to the lab. So in our lab work on the Chobham Common core, we're going to be looking at 4 different things. The first thing we're going to look at is those diatoms that I mentioned earlier. So we'll identify what different species of diatoms there are found in the sediment at Chobham Common and look at how the assemblage of them changes over time. Diatoms are really sensitive to changes in environmental conditions, so they make really good indicators to give us a detailed picture of how things like water temperatures changed, acidities changed, salinities changed. So we'll wait and see what results we get from those. We're also going to be looking at macrofossils, which are the remains of bits of seeds, bits of leaves, other kind of small invertebrate remains, and those can tell us a more detailed picture about the local vegetation in a site. So we'll be able to see, has it changed between being perhaps more ephemeral, perhaps more wooded around the area, if there was more grass rather than trees, so we'll be able to see some trends from those as well. And the last 2 things we're going to be looking at are something called SCPs and macrocharcoal. So the SCPs, or spheroidal carbonaceous particles, which is a bit of a mouthful, are a type of ash that is only produced through fossil fuel burning. So you can use them to give you a rough dating of your core, because you can look back through the core and see where they might have peaked in the 1950s and then when they really drop off prior to that. And then when you find them completely absent, you know you've reached the Industrial Revolution, because they wouldn't have existed naturally at all. They only exist from fossil fuel combustion. Lastly, the macrocharcoal is what we're going to use to give us a bit of an insight into the fire history at Chobham Common. because as you'd imagine, when there are wildfires, it leaves behind charcoal remains in the sediment. So we can basically count the pieces of charcoal we find and be able to identify when there were really big fires, where there were no fires, and see how that changes over time and how that might correlate with some of the other indicators that we're looking at as well. The preliminary results we've had so far have given us a little bit to go on so far with Chobham Common, especially at Bee Garden Pond. So we found that the SCPs disappeared about 30 centimetres down, and there's 10 centimetres under that. So we know that the core goes back at least to the Industrial Revolution, and definitely a little bit before that as well. We've also got some results from the macro charcoal that have, unsurprisingly, very high levels of macro charcoal over the last 50 years, and then it really drops off. It's quite interesting because then when you get back to the Industrial Revolution, it starts to increase again. So it may be linked to the military presence between the 1850s and the 1950s at Chobham. Once we get our results from the diatoms and the macrofossils, it will start to paint a more fuller picture of what's going on. I'm really pleased to say that the first piece of work from my PhD has now been published. This wasn't related to the sediment core at Chobham Common, but it was related to a survey that some of you may have completed for me. So I had a survey go out to ask conservation practitioners what they think about paleoecology, whether they'd like to use it, what they think the barriers to that might be, and what they think some of the solutions would be. We had about 150 people reply and give us some really useful insights into what they thought. We found that in general, people were really keen, although they did have a mixed understanding of what it meant. They wanted to know how they could use it more, especially to look at things like their past site condition or past species assemblages. But unsurprisingly, they did come up with that things like money, time, expertise were big barriers for them, but also poor communication from the academic community. So the solutions that kind of came out of that were having more case studies with more applied work to inform people what is in the realm of the possible. They wanted an online database that might be related to having some GIS as well to give them more access to the data. And they also wanted to see it used in conjunction with things like biodiversity net gain and other policy drivers that really dictate what conservation practitioners do on a day-to-day basis. So the next steps for that will be developing some case studies based on the recommendations and saying, okay, can we make it work in this way? And that's what I'll be going to work on over the next year or so. Hopefully that gives you a bit of a flavour of some of the work I've been up to this year as part of the Space4Nature project. I'm really looking forward to giving you another update at the next one of these events, but if you have any questions, please feel free to get in touch with the meantime. I'll see you guys soon.